Hello, welcome to Chapter 9, homework questions 59 through 64. Question 59, solve the inequalities below for the given variables. Represent your solutions on a number line. So let's go ahead and start with problem A. Now remember, when we start an inequality, we want to solve for the boundary point. So we're going to change this to an equation. I'm also going to go ahead and distribute the 3. So 6k minus 3 is equal to 9. And then we solve it just like we solve an equation. We add 3, and then we divide by 6. So we know the boundary point is at x, or in this case k, equals 2. So we know on our number line that we have 0, 1, and 2. And so at 2, we either have an open or a closed circle, and that all depends on, are we including that value of 2 as a solution or not? Well, look at your inequality. It's less than 9, so it's not equal to, so therefore we do not include it. We're just going to leave it as an open circle. And now, do we want the points to the left of 2 or to the right? I should say the numbers. To the left of 2 or to the right of 2? And to find out, we're going to take any number. In this case, I'm going to choose 0. It's usually the easiest. I'm going to plug it in for k. And go back up to, I actually should go back up to the very original, so I'll do 3 times 2 times 0 minus 1, and that has to be less than 9. So that would be 3, 0 minus 1 is negative 1, and we get negative 3 is less than 9. Is negative 3 less than 9? Yes, it is. And since negative 3 is less than 9, remember, we just plugged in the value 0. And so since it's true on this side, then all of these values will be true. Anything less than 2 will be true. So we have the number line, but we also need to write the inequality that k is less than 2 is our solution. All right, on to part B. 2p divided by 5 is less than or equal to 6. I'm going to say it's equal to 6 so I can solve it. Multiply both sides by 5. Get rid of that denominator, and then divide by 2, and we get p equals 15. So on our number line, once again, here's 0, we got 15 all the way down here, okay, and we're looking at, is it included again? Is it part of our solution? So we go back to the inequality. It is less than or equal to, so that means it is part of the solution, so we're going to fill in our circle. And then we want to know, once again, are the solutions to the left of 15 or to the right of 15? And so I'm going to plug in the number 0 again. 2 times 0 divided by 5 is less than or equal to 6. Well, 2 times 0 is 0. 0 divided by 5 is 0. So is 0 less than or equal to 6? Yes, that is a true statement. So all the way over here at 0 is true, which means all of these values over here are also true. And then our inequality would be that p is less than or equal to 15. Let's take a look at C. We have negative 2 plus 8n, and I'm going to change it to an equal sign, equals 2. Once again, we're going to continue to solve for the boundary point. We get 8n equals 4, divide by 8, and n is equal to 1/2. And so, all right, set up our number line. At 1/2, we have 0, 1, and then 1/2 would be in the middle. And do we include 1/2 or not? Well, this one is greater than, so it doesn't have the equal to sign, so we don't include the 1/2. And then we test the point to see if it is true or false. So we'll do 0 again, and I'll continue to choose 0 as long as I can because it cancels things out nicely and usually makes it pretty easy to check. So this one's negative 2 is greater than 2. Is negative 2 greater than 2? No, it is not. So at 0, that's not a true statement. So we want to go to the right on this one. So our answer is values of n that are greater than 1/2. All right, and then our last one, D, 7t minus 4. Find our boundary point by setting it equal to 2t minus 4. Solve the equation We have 5t minus 4 equals negative 4. Add 4 to both sides. Anytime you have multiple variables, you want to get the variable on the same side and the constant on the other. And so it looks like our boundary point on this one is at 0. So on our number line, we have 0. And then we have a number 1, 2, 3 to the right, negative 1, negative 2, 3 to the left. So once again, same question. Do we include 0 or not? Well, it's greater than. So it doesn't include that value, so it will be an open circle. Now, we can't test the point 0 because it's our boundary point, so I have to pick something else. So I'm just going to pick 1. 7 times 1 minus 4 is equal to 2 times 1 minus 4. That 7 minus 4 is 3. Oh, I forgot I need to fix this. It's not equal to anymore. We got to go back to the original inequality. So 7 times 1 minus 4 is greater than 2 times 1 minus 4. So therefore 3 is greater than 2 minus 4 is negative 2. So is 3 greater than 2? Yes, it is. So at that point, since we tested the number 1 this time, and it's true, then we will go to the right of 0. So all values of t that are greater than 0. So make sure on these problems that you do have the number line that it asks for. And also, you want to represent your solutions as an inequality as well. Question 60. Brett is working in the chemistry lab trying to determine if he can predict the volume of 3 different gases, nitrogen, oxygen, and carbon dioxide, based upon the pressure applied to them. He kept all other characteristics of the gases constant. Brett performed the following analysis. So you are given all this information. You are given the least squared regression line, which is located right here. You're given the scatter plot, which is the first graph. The second graph is your residuals, which it says right here on the y-axis. And then you're given all the data up here in your table. So you're given all the information. You're also given the R value, the correlation coefficient. So all the information is provided for you. You need to go through and answer each of the questions. So on part A, it says discuss the association, including the slope and the R squared value. So I went ahead and once again, instead of trying to type all this out, I went ahead and just took the answer key so you guys could see what the answers were. So if we're going to discuss the association, we got to discuss the strength. So there is a strong negative linear association between the pressure and the volume of these 3 gases. So you can say it's strong, okay, because of the, going back up to the correlation coefficient, the R equals negative 0.903, so we know it is strong because that number is close to -1. We also know that it is negative because the R value is negative, and also not only is the R value negative, your slope is negative as well. So both of those reasons we know it is negative. So we got a strong negative linear association. There are no apparent outliers. It doesn't seem like there's any points too far away from the data. You might initially think that this might be, but it's not extraneous. It's not really far away, so I'd say no outliers. The residual plot indicates a curved model might be a better fit than a linear model. So it looks like we might have a pattern here. We don't necessarily have points scattered all around. We might have more of a curved model involved here. About 82% of the variation in the volume of the gases is explained by a linear relationship with the pressure. So remember that 82% comes from taking the R value of negative 0.903 and squaring it. So you get this value to be approximately 0.815, which is why they rounded to 82%. And then the last thing, on average, this is your slope, on average, for every increase in 1 atmosphere at a constant temperature, the volume decreases by 1.65 liters. And so once again, going back to the 1.65 from up here, that is your slope. All right, part B, what is the residual with the greatest magnitude and what point does it belong to? So looking at your residual plot, which point seems to be farthest away? Pay attention, this is at 2.5 and negative 2.5. So this one is somewhere here. Looks like this one on top with the triangle, which represents oxygen, would be the largest residual value. And the largest residual value is about 2.3 atmospheres, and it belongs to oxygen at 2 atmospheres of pressure. Part C, using the least squared regression line model, estimate the volume of a gas at 2.5, 4.5, and 6.5 atmospheres using an appropriate precision. So we're going to use our least squared regression model, which is y is equal to 13.51 minus 1.65 times x, and we'll just plug in the 3 different values: 2.5, 4.5, and 6.5 into each of these equations, and we'll figure out what each of them are. Now, when I plugged it in, I got a y value on the first one to 2 places, because that's what the rest of them are on the table, of 9.39, and then on 4.5 I got 6.09, and then the last one I got y equals 2.79. When I go to look at the answer key, though, they have close to what I have, but a little bit off on each of those, so I'm not sure as to why that is. But they are represented in liters, so make sure you write that for Part C. All right, and Part D says, how well would this linear model work in predicting more extreme pressures and support your answer? So we kind of already know a different model will be better because of the residual plot and the pattern that it has. It does say there is a curved pattern in the residual plot. In fact, by the ideal gas law, pressure and volume have an inverse relationship. After 8.19 atmospheres of pressure, the linear model will start predicting negative volumes. Students may know at some point the gases will condense into liquids and have much different physical characteristics. So, once again, don't need all that information, but we do know that a different model would be a better model. Question 61. Use your graphing shortcuts to graph y equals negative 2x plus 3. Identify the x and the y intercepts. So it's in slope-intercept form, so it seems to be that maybe we can just identify the slope as negative 2 and the y-intercept at 0, 3. So if we are graphing it, that's enough information to graph. So at 0, 3, slope is down 2 to the right 1. We'll get a couple of those points in. And then graph our line. So that would be kind of a sketch of our graph there. And then it wants us to identify the x and the y-intercepts. Well, we know what the y-intercept is because it's given to us in slope-intercept form. So we know the y-intercept is 0, 3. It would have been nice if it crossed the x-intercept nicely on my graph, but it didn't. So I don't know exactly what the x-intercept is. So to find the x-intercept, though, we know that the y value is 0. So we can plug 0 in for y and solve for the x value. So negative 3 is equal to negative 2x divided by negative 2, and x is equal to 1.5. And so my x-intercept is at 1.5 comma 0. So make sure you find the 2 intercepts and you also graph it. Question 62. Find the equation of the line with slope negative 3/5 passing through the point negative 6, 2. So this is a linear equation. Our slope, it gives us is negative 3/5, and since it gives us a point, it gives us an x and a y to use to be able to find the missing part, which is the y-intercept, or b. So y is 2, slope of negative 3/5 times negative 6, and then plus b. So I can multiply negative 3/5 times negative 6, and I can just multiply straight across as a fraction, which is 18/5, but it might be easier to write that as a decimal, so when we go to subtract it, either way is fine. This would be 3.6 plus b, and then we can subtract 3.6, and we get b is equal to negative 1.6. And so to find the equation of the line, now we have the information. The equation is y equals negative 3 over 5x minus 1.6. Question 63. Solve the quadratic equation below. Check your solutions with a calculator. So let's go ahead and set it equal to 0. We might already have an idea before we get started, but in terms of how we're going to solve this, but let's go ahead and set it equal to 0 to get a better idea of what we're looking at here. And so when we do that, we notice obviously before as well that we have decimals. And so maybe trying to factor this is not going to be the best way to solve. So we're probably not going to be able to use our zero product property. Completing the square, the numbers once again are just, not that we can't do it, it's just really crazy right now with the decimals and the 3. So I think it looks like a quadratic formula is going to be our best bet on being able to solve this efficiently. So x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So we need to identify what is the a value. A is 3. What is the b value? 2.5, and c is negative 12.5. Remember, these are the numbers in front of your x squared term, your x, and then your constant at the end. Make sure you get your positive and negatives correct on there. Now you're going to take a, b, and c, those numbers, and plug it into your quadratic formula. So we'll get the opposite of b, so the opposite of 2.5 plus or minus the square root of 2.5 squared minus 4 times 3 times the c value of negative 12.5. All of that is divided by 2 times 3. And then we just start simplifying. The opposite of 2.5 is negative 2.5 plus or minus. And I'm just going to plug that whole expression in to my calculator to see what number I get. And I have 156.25 divided by 6. And so we'll separate this into our two parts. Negative 2.5 minus the square root of that divided by 6. And we'll figure out what that approximation is. And negative 2.5 plus the square root of 156.25 divided by 6 and figure out what that approximately is. So when I plugged it in, I got negative 2.5. So actually, it's not an approximation because it worked out nicely, even though the square root of 156.25 doesn't seem like it would be necessarily a nice number. It ended up working out nicely. So we got two answers, negative 2.5 or negative 5/2, and 1 2/3 or 5/3. So those would be the solutions to the quadratic equation. Now, so negative 2.5 and 5/3 would be our solutions. Then we could check using the graphing calculator. You can either set it equal to 0, plug the 3x squared plus 2.5x minus 12.5 in your calculator, see where it crosses the x-axis, or plug these in separately, and then you'd have to see where they intersect at. So either one would be fine. You could also check your solutions by plugging them back in, but it says specifically using a calculator. So either way, though, is fine. Question 64. Factor the expressions below completely if possible. So since it says completely, it kind of gives us an indication that we might have some common factors in here that we will have to deal with. On the first one, there's no common factors. There's no common number that goes into 4, 20, and 25. But what you might notice is that the first term is a perfect square, and the last term is a perfect square. So this might be a perfect square trinomial. Remember, if this is correct, this would give us a 2x and a 5. And our middle term should be 2 times these two numbers. So 2 times 2x times 5, that's 4x. 4x times 5 is 20x. So it does look like it is a perfect square trinomial. So since it's minus 20x, that would be 2x minus 5 times 2x minus 5. And if you're not sure, you can always distribute that back through and check to see that it is correct. Remember, you could also write it as 2x minus 5 quantity squared. Part B, we have x squared plus 11x plus 2. And you might notice right away on this one, to get a positive 2 and a middle term of 11x, actually that looks like a minus 2, sorry about that. But either way, to get 11x doesn't seem very reasonable. But to double check, we get an x squared here and a negative 2, and we're looking for factors that multiply to give us negative 2x squared, but add to give us 11x. So the only factors we have for 2 are 2 and 1. One of them would have to be a negative, but we're not going to get anywhere close to 11x. So this is what we would call prime. It only has two factors, one in itself, or we can say that it is non-factorable. All right. C, 3x squared minus 12x. So I'm going to show this using the generic rectangle, but I'm also going to show you, if you notice something ahead of time in terms of what's in common, we can kind of shorten that process up a little bit. So the generic rectangle would look like this. We have 3x squared. We don't have any one tiles, so that's 0. So we're looking for numbers that multiply to give us 0x squared, but add to give us negative 12x. Well, if it's going to multiply to give us 0, one of the numbers has to be 0, and if it's going to add to give you negative 12x, then you have to have the other one to be negative 12x. And so when you set this up, it looks a little different here, but what you have is you have a 3x here times x will give you 3x squared, and then the minus 4 would give you negative 12x, and then x times 0 is going to give you 0x. And so this factors to 3x plus 0, or you could just say 3x, and then x minus 4. And so that would be factored completely. But I also want you to look at, your last term is missing, and so you're going to have those common factors of at least an x, but there's also a 3. So I'm going to work backwards from the distributive property, and I'm going to divide by 3x, which means I'm going to take the 3x out of the original problem, because I'm working backwards of the distributive property. I'm going to divide, and 3x squared divided by 3x is just x, and negative 12x divided by 3x would be 4. So that's another way that you can do that if you recognize that there is a common factor. Are these two the same thing? And they are. This one just has a 3x plus 0 in there because we used the generic rectangle. And on D, we have 10x squared minus 35x minus 20. Once again, before jumping into the generic rectangle, which we can do, since we want to make sure we factor this completely, are there any common factors? And there is a common factor of 5. So we'll do the same thing, divide by 5, which means we're allowed to take that 5 out. Working backwards, that's 2x squared minus 7x minus 4. Now, we're not done just because we've done that one part. We want to check to see if we can factor any more. So we're looking for factors of, we got 2x squared and negative 4. So what multiplies to give us negative 8x squared and adds to give us negative 7x. And so that would be negative 8x and positive 1x. And so we can figure out our side lengths. This would be a 2x times an x, and then minus 4, and then that would be a plus 1. So this finally factors out to three different things, 5, and then 2x plus 1, and x minus 4. So that would be factored completely.